A satellite is any object that moves in a curved path around a planet. Like Moon in space is Earth's natural satellite. The path a moon follows is an orbit, which sometimes takes the shape of a circle. There is man-made artificial satellite. An artificial satellite is an object, typically a spacecraft or machine, placed into orbit around a celestial body. There are thousands of artificial satellites orbiting Earth right now. They have a variety of uses, including communication relay, weather forecasting, navigation, GPS, broadcasting, scientific research, and Earth observation. How do you launch a satellite into space? To launch a satellite into space, a launch vehicle is used, such as a rocket. This rocket is divided into multiple stages. This process is known as staging. In this method, one giant rocket is divided into several smaller booster rockets, 2 or 3 small parts that fall away at different launch stages. And the satellite is fixed on the uppermost side of the rocket, called the nose cone. In the first steps, the booster gives the rocket its initial thrust during launch and carries the rocket through the early part of the flight. And the rocket travels straight up only for a few kilometers. As the fuel in the booster is used up, the booster rockets fall away. And the other booster takes over. Each time a booster is dropped, the rocket gets lighter and travels faster. When it finally reaches the proper altitude and speed, at that point, rockets are fired and ensure separation between the launch vehicle and the satellite itself. And finally it releases the satellite into space. When the satellite is released, it opens all its solar panels to get the power from the solar system. Does a satellite fly in a straight line into space? The answer is no, the satellite flies in orbit around the Earth. But how does the satellite stay in orbit? The answer of this question is explained by the Newton's law of universal gravitation. That every particle attracts every other particle in the universe with force directly proportional to the product of the masses and inversely proportional to the square of the distance between them. When a satellite is thousands of miles away, Earth's gravity still has an effect on it. That tug toward Earth, combined with the momentum from the rocket, which is approximately 17,000 miles per hour, or 27,359 kilometers per hour at an altitude of 150 miles or 242 kilometers, causes the satellite to follow a circular path around Earth, an orbit. If the satellite goes too fast, it will eventually fly away even if the gravity force is working on it. On the other hand, if the satellite goes too slowly, gravity will pull it back to Earth. At the correct orbit velocity, gravity exactly balances the satellite into orbit. Does satellite need fuel to orbit? This is one of the most asked questions. The answer is no, the satellite fly into orbit does not require fuel. The force initially imparted on the satellite when the rocket puts it in the orbit is enough to give the body the kinetic energy to move in a circular orbit. Why satellites are in different orbits? Earth's magnetic field is divided into 2 sets of poles. The upper part is called the North Pole, and the lower part is called the South Pole. What is the equator? The equator is an invisible circle that lies halfway between the North and South Poles, crossing horizontally around the middle of the Earth at 0 degrees latitude. What is an orbit? An orbit is the path an object in space travels around another. Like the Moon, travel around the Earth, and the path the Moon follows is called an orbit. An orbit is a curved path. A lot of orbits are shaped like a circle. And some orbits are elliptical orbits. Satellites are usually classified based on their orbital altitude, which directly affects their coverage and the speed and function at which they travel around the Earth. There are 4 main types of satellites orbits. Low Earth orbit, LEO. Medium Earth orbit, MEO. Geostationary orbit, GEO. Sun-Synchronous orbit, SSO. Low Earth orbit, LEO. Low Earth orbit satellites are moving at an altitude of roughly 180 to 2,000 kilometers above the Earth's surface. Low Earth orbit travel at approximately 7.8 kilometers per second with respect to Earth, completing an orbit in between 90 and 120 minutes, meaning they can travel around the planet up to 16 times a day. This makes them particularly well suited to all types of remote sensing, high-resolution Earth observation, and scientific research. Medium Earth orbit, MEO. A medium Earth orbit satellites are moving at an altitude of roughly 5,000 to 20,000 kilometers above the Earth's surface. Compared to low Earth orbit spacecraft, MEO ones require fewer devices to give worldwide coverage, but their time delay is longer and their signals are weaker. Positioning and navigation services, like GPS, extensively use MEO type of satellites. Geostationary orbit, GEO. Geostationary Earth orbit satellites are positioned 35,786 kilometers above Earth's surface, precisely over the equator. Moving from west to east, exactly matching Earth's rotation, taking 23 hours 56 minutes and 4 seconds to complete one full orbit. This allows a terrestrial antenna to always point toward the same device in space. That's why this type of satellites is perfect for always-on communication services like TV and phones. Sun-Synchronous orbit, SSO. Sun-Synchronous orbit satellite are moving from north to south across the polar regions at an altitude of 600 to 800 kilometers above the Earth. Sun-Synchronous orbit is a particular kind of polar orbit in which satellites are in sync with the Sun. Matching Earth's rotation around the Sun, they always appear in the same position relative to our star. This means they pass over the same spot on Earth at the same local time every day. Now you might think about why satellites do not collide with each other. There are thousands of satellites orbiting Earth. But 99% satellites do not collide with each other in space. Collisions are rare because satellites are launched in different orbital altitudes, which means they follow distinct paths around Earth. These differences in orbits help minimize the chance of collisions. There are specific regulations and guidelines for satellite operators to ensure safe separation between satellites. Such as NOAA, NASA and other US and international organizations keep track of satellites in space, and actively manage satellites in orbit. They monitor the positions and trajectories of satellites to predict potential collisions and provide warnings to operators to adjust orbits if needed. In February 2009, two communications satellites, one American and one Russian, collided in space. However, it is believed to be the first time two man-made satellites have collided accidentally. What is inside a typical satellite? Satellites are classified according to their orbits and their functions, for example, weather satellites, communication satellites, Earth observation satellites, military satellites, and navigation satellites. Different countries design different shapes and sizes of satellites. All satellites have different characteristics and different missions. No matter what they are used for, they all have several things in common. Body or bus. The body or bus of the satellite provides the necessary support for all satellite components. The body is designed to withstand the mechanical stresses experienced during powered flight, including liftoff and acceleration, noise, and temperature differences. Antenna. Satellites depend on communication, and antennas are essential for enabling data transmission. Satellites need to upload and download some specific data. Large antennas are used in satellites to provide smooth data transfer when transmitting high-quality data to Earth. Camera. Cameras aboard satellites are vital components in space missions. Camera systems are outfitted with advanced imaging sensors and lenses. These cameras serve various purposes, including verifying the performance of system elements and events during launches, such as rocket staging, fairing deployment, spacecraft ejection, and operations on satellites like antenna and solar panel deployment, sensor mechanical operation, and subsatellite ejection. Attitude controller. This system serves the purpose of maintaining, adjusting, and correcting the satellite. The attitude controller provides 3-axis stabilized Earth-pointing attitude control during all mission modes and measures spacecraft rates and orbital position. It consists of sensors, small thrusters, and calculators. Solar panel. A satellite must operate 365 days a year revolving and collecting data. To operate the several electronic systems and devices, satellites need power. Without power, a satellite can't do anything. The most readily available source of power is the sun. So satellites use solar panel arrays to convert solar energy into electrical energy. The biggest part of the satellite is solar panels. Solar panel automatically adjusts its direction with the sun lights. And high-performance batteries are also used to get power when the satellite is screened by the Earth during eclipses. How does a satellite work? Satellites play vital roles in our daily lives. We are using satellites in different areas like communication, transportation, aviation, and maritime, environmental monitoring, disaster management, sustainable agriculture, natural resource management, and much more. Satellites help communicate with people across the globe. For example, if we have 2 ground stations, one is on this side of the Earth, and the other is on the opposite side of the Earth. And if both want to communicate with each other, there is no line of sight between them because of the curved nature of the Earth. So they cannot communicate with each other. If there is a satellite, the ground station sends a signal to the satellite. This process is called an uplink. The satellite receives the signal, amplifies the signal, and retransmits it to the other ground station. This process is called downlink. How many satellites do we need to achieve global coverage? Communication satellites are placed in geo orbit. Geocommunications satellites take advantage of their wide orbit and high location, and only 2 satellites with proper positioning in geosynchronous orbit are enough to achieve global coverage and services. Thank you for watching. Please subscribe to Star Technology. Please like and share the video.